Hello everyone, and welcome to this technical explainer. Today we're taking a really fascinating deep dive into the world of industrial robotics. Whether you're an engineering student, a professional working in the manufacturing sector right here in Tamil Nadu, or honestly just someone curious about how modern tech is shaping our world, you are exactly in the right place. We're going to decode exactly how machines are taking over the heavy lifting, quite literally, in factories all around the globe. I want you to think about this question for a second. Have you ever wondered how giant factories manage to churn out thousands of identical products, achieving zero-error 24/7 production without ever taking a break? Well, the answer isn't magic, and it's certainly not human endurance. The secret actually lies in eliminating human physical limitations entirely through highly advanced, meticulously programmed machinery. Okay, let's dive right into this. Here is our roadmap for today. 1. Introduction to robotic automation. 2. Robot anatomy and components. 3. Step-by-step working process. 4. Types of robots. 5. Applications and benefits. And finally, 6. Smart automation and DEVI automation solutions. Let's get started. Section 1. Introduction to robotic automation. It really comes down to a pretty simple comparison. Human labor is incredible, but at the end of the day, we're biology, not machinery. We're prone to fatigue, our attention spans waver, which leads to minor errors, and we just naturally have physical speed limits. Robot automation, on the other hand, flips that script entirely. These machines offer blindingly high speeds, extreme micromillimeter accuracy, and the ability to operate continuously. We're talking 24 hours a day, 7 days a week, without stopping. So the crucial point is this. When we talk about a pick-and-place robot, we're really talking about the ultimate solution to repetitive manufacturing. By definition, it's an automated machine specifically engineered to pick up items from one location and place them with absolute pinpoint accuracy in another. It completely replaces those dull, highly repetitive human tasks, which honestly frees us up for much more complex, creative problem solving. Section 2. Robot anatomy and components. To make this super easy to visualize, we're going to compare the anatomy of a robot directly to the human body. Let's start with the mechanical body. Just like us, a robot needs a stable foundation, which is the robot base. Extending from that is the robot arm, functioning a lot like your own arm to provide reach and flexibility. Then you have the servo motors. Think of these as the muscles of the robot. They provide all the immense power and precise movement. Down at the end of the arm is the gripper, or what engineers call the end effector, acting exactly like a human hand grabbing an object. And finally, the conveyor system is the delivery mechanism, constantly bringing items right into the robot's workspace. But a body is totally useless without a brain and senses. And this brilliantly illustrates how that works for a machine. The sensors and vision cameras act as the robot's eyes, detecting exactly where objects are in real time. Then you have the PLC, or Programmable Logic Controller, and the robot controller. These act as the central brain, instantly processing what the eyes see and making lightning-fast decisions. The HMI, or human-machine interface, well, that's basically the screen where human operators can talk to this brain and give it new instructions. Section 3. Step-by-step working process. So how does this anatomy actually work together in real time on a fast-paced factory floor? Let's trace the journey of a single part, just to see it in motion. It all happens in 5 rapid, seamless steps. Step 1. An item moves down the line and a sensor instantly detects it. Step 2. The PLC processes the signal and sends a split-second command to the robot controller. Step 3. The motors flex and the robot arm swings into exact position. Step 4. The gripper closes, accurately grabbing the item. And finally, Step 5. The arm moves to the target destination and places the item perfectly. This loop repeats over and over, thousands of times a day, without a single micromillimeter of error. It's truly amazing to watch. Let's move to Section 4 and see how this builds into the types of robots. Just like in nature, there are different species of robots adapted for very different factory environments. Depending entirely on the speed and the setup required, engineers choose from a variety of options. You have Cartesian robots that move in straight, rigid lines, kind of like a massive 3D printer. You have SCADA robots, which are incredibly fast for lateral, side-to-side assembly. Delta robots look like mechanical spiders and are wildly fast at picking lightweight items. Some can execute an incredible 300 picks per minute. That's 5 a second. Articulated robots look like giant human arms and offer maximum flexibility. And finally, collaborative robots, or cobots, are specially designed with force limiters so they can actually work safely right alongside human workers.
Section 5. Applications and Benefits.
Where do these incredible machines actually live and work? The versatility of a pick-and-place robot is honestly staggering. They're boxing up products in the packaging industry, they're placing microscopic microchips on motherboards in electronics assembly, they're handling heavy car parts in the automobile industry. You'll find them maintaining sterile environments in food processing and pharmaceuticals, organizing goods in warehouse automation, sorting items in huge logistics centers, and tirelessly loading and unloading raw materials into CNC machines. They are everywhere. Now, what's really interesting about this slide is it perfectly answers the question we asked at the very beginning of this explainer. Why do factories use them? Because they deliver unmatched speed and high precision. They allow for 24/7 continuous operation, which drastically increases production volume. By taking humans out of dangerous, repetitive tasks, they significantly enhance workplace safety, reduce human error to zero, and ultimately result in lower overall production costs. It is an absolute win-win for modern manufacturing. Section 6. Smart Automation and DEVI Automation Solutions.
We've talked a lot about what robots do today, but the future is Industry 4.0. It's about transforming these standalone robots into fully connected, smart automation systems. By integrating those PLCs and HMIs with SCADA monitoring systems, artificial intelligence, and the Industrial Internet of Things, or IIoT, these machines can now actually predict when they need maintenance and learn to optimize their own paths. And for the ITI, Diploma, and BE students tuning in, this technological explosion is creating massive, high-paying career growth for technical professionals who know how to program and maintain these integrated systems.
If you're looking to bridge the gap between just learning about these technologies and actually implementing them in the real world, you need to know about DEVI Automation Solutions. They are a premier provider for these cutting-edge services. They specialize in industrial automation, PLC programming, SCADA systems, as well as AI and IoT integrations. But they don't even stop at factories. They also provide brilliant solutions for smart agriculture, home automation, and solar integrations. If you want to connect with industry experts who are actively building a better tomorrow with smart technology, you can reach out to them directly at deviaautomationsolutions@gmail.com. That brings us to the end of our journey today, but the learning definitely doesn't stop here. Which automation or robotics topics should we cover next? Let us know down in the comments. If you found this explainer helpful, please hit that like button, share it with your fellow students and colleagues, and make sure to subscribe to the DEVI Automation Solutions channel and hit the bell icon so you never miss out on our future technical deep dives. I'll leave you with this final thought. If robots are now the tireless muscles of the factory floor, and AI is rapidly becoming the brain, what incredible innovations will human creativity be freed up to design next? Thank you so much for joining me, and stay curious.